Hey guys, hope you're having a good day. I'll post the key to this review. This is the review you're working on Monday and Tuesday. You need to have this done by Wednesday the 27th for a daily grade and +5 on your quiz. You will have a big quiz this day on the 27th. Okay, so since I'm not here for today and tomorrow, I wanted to post a video of myself going through and working some of these problems just in case you cannot figure out something from your notes or if you just need a reminder on how to do some of this stuff. So I really want you guys to be sure you're filling in the mole map. Okay, this is the most important thing, especially if you're still getting stuck in places. This map is your key to help you get unstuck. Okay, so this whole half is all about converting to moles of given. Okay, and by given, I mean what I asked you about in your problem, or what I gave you in your problem. This whole half is about converting out of moles of your wanted, or what you're converting to. Okay, this step right here is where everything important happens this unit. This is your mole ratio step. Okay, the minute you drop moles of given to the bottom and you get moles of wanted on top, this is your mole ratio step. Okay, and we use our coefficients from that balanced chemical reaction. So if you need to pause the video to finish out your stoichiometry map, go ahead and do so. If you want to put your conversions in here, you can as well. 1 mole equals 6.02 times 10 to the 23rd particles, or FAM. To get from mass to moles, remember it's 1 mole equals the molar mass. Right, and this is where you use your periodic table. Gee, I better look at my periodic table. Same conversions over here. Okay, so this is what you're going to come back to anytime you get stuck or anytime you don't know where to start. Okay, so the new thing for this unit, like all of this is old news, all of this is old news. We learned that last unit and y'all did awesome on that test. The new thing for us this unit is this mole ratio step. Okay, so make sure you always have a balanced chemical reaction because you need those coefficients for that mole ratio step. So this reaction with these coefficients, what is the mole ratio? Okay, oops, I accidentally gave you too many spots. You don't need that spot. So 2 to 2 to 3, right? I also want you to be sure you can do it for to compare two elements. So let's say for potassium chloride and oxygen, I've got 2 potassium chlorides and 3 oxygens. Okay, this is the conventional way to write ratios, but we write them in these conversion factors in stoichiometry, in dimensional analysis. Okay, so to fill that in, you've got 2 moles of KCl and 3 moles of oxygen. Okay, this is that mole ratio step that I'm talking about here. So let's practice using the mole map to solve some of these mole problems. So how many moles of oxygen are produced when 6 moles of potassium chlorate decompose completely? So this is my given. This is the only thing I was given information about. So you always start with your given over 1. And guys, I'm noticing, at least today, it's only Thursday today, maybe tomorrow it'll be a little better, but I'm still noticing people not putting their units. You need your units and you need your substance. Otherwise, you're going to get completely lost in those longer problems, okay? So you've got moles of KClO3. Before you even really care what you're doing or what your end goal is, you just open up another conversion and drop your units. Okay, so moles of KClO3 on the bottom. If you don't know what to do next, it's okay, because you have this mole map. We are in moles of KClO3, moles of my given. So I'm on the given half of my map and I'm here. I'm not in grams, I'm not in particles, I'm in moles. So my next step, my only option is this next circle, right? Like the only way to go is over here, and you put moles of wanted on top. So moles of wanted on top, what do I want? I want moles of oxygen. Okay, so this is my step. This is my mole ratio step. The minute you have moles of wanted on top over moles of given, you use your coefficients. So I have 3 moles of O2 and 2 moles of KCl. I've canceled out moles of KClO3, and I am in moles of O2, which is exactly what I asked for. So to solve this, you multiply everything on the top, 6 times 3, and then divide by anything on the bottom, and I get 9. 9 what? 9 moles of oxygen. Okay, so you've got a couple more practice problems for, actually just one more practice problem on mole to mole stoichiometry. I'm not going to work that one out, but the key will be posted on its learning, where you found this video. So let's do one that will be maybe a little bit longer, because now we're not just going straight from mole to mole. So be sure you've got a balanced chemical reaction. I have a feeling this is going to be one of those ones where I just go back and forth. So I need 4 times 3 is 12, so I need 6 chlorines. So here's my balanced chemical reaction. I need that because I need these coefficients for my mole ratio step. Okay, let me just double check really fast that that's right. 4 aluminums, 4 aluminums. 6 oxygens, 6 oxygens. 12 chlorines, 12 chlorines. Okay. So this one, I immediately just circle what I was given and circle what I want. Okay, it helps keep me organized. And I put what I was given over 1. You better be putting your unit and your substance. Okay, and then when you open up your next conversion, you will take both the unit and the substance and drop it to the bottom. When I say drop your units, I mean the unit and the substance. Okay, so if you don't know what to do from here, no problem. Here's your mole map. Okay, I'm in grams of my given. I'm way over here. Okay, so I've dropped my units. I don't know what goes on top. This tells me what goes on top. This is my only option. So moles of my given. This is a mistake I see a lot of people make. They immediately put moles of O2. Okay, you can't get to moles of wanted yet. Right? You can only go from mass of your given to moles of your given. So moles of Al2O3. This is not my mole ratio step. This is not the step where I've got moles of given on the bottom and moles of wanted on top. Okay, so I don't do coefficients yet. Right now, it's still 1 mole equals the mass of aluminum oxide. To find the mass of aluminum oxide, I see the letter G. G, I better look at the periodic table. And I see that aluminum is 26.98, and I have 2 of them. So 26.98 times 2. And I see that I have 3 oxygens. Each one weighs 16 atomic mass units. That gives me 101.96 grams. Okay, cool. So I've canceled out aluminum oxide. I am in moles of aluminum oxide. That's not what I want. I want moles of oxygen. So open up a step, drop your units. Okay, so here I am. Moles are given, and this is what I put on top. Moles are wanted. Moles of O2. Okay, this is my step. My mole step. Moles are given on the bottom, moles are wanted on top. I'm going to use 2 for moles of aluminum oxide and 3 moles of oxygen. I've canceled out moles of aluminum oxide and I'm in moles of oxygen, and that's exactly what I asked for. So you are done. You don't have to set up any more steps. Okay, so to solve that, my computer just went off. I hope that this is still recording. Yeah. Okay, so to solve that, I multiply the top, 5.25 times 3, divide by the bottom, 101.96, divide by, again, the other thing on the bottom, and I get 0.07 or 0.08 when you round, moles of O2. Okay, so again, I'm not going to work number 6 and 7 out. Those you can find on the key on It's Learning. Okay, but it's going to be the same process. You're not always going from grams to moles. Some of the time you're going to go from moles to grams, but it's the same process. Start with your given, put it over 1, open your next conversion, and drop your units. If you get stuck and you don't know where to go, use your mole map and you see what comes next, what you'll put on top. So I'm going to stop the video here and do the next section in a separate video.